So let's focus now on angles. Let's talk about some important angle relationships. And before we actually get into applying those relationships, we got to work on some vocab. So complementary angles are two angles whose sum is 90 degrees. Whoa, why is that so big? Let me make that smaller. 90 degrees, okay? So you notice in this two diagrams, they could be right next to each other, like in this diagram, or they could be separate, like in this diagram. But either way, two angles that add together to give you 90 degrees. So one thing we can say is if an angle is x, degrees, its complement is 90 minus x degrees. So like if an angle is 10, its complement is going to be 90 minus 10. All right, supplementary, if you look at those diagrams, hopefully you can tell that the relationship between supplementary angles is that their sum is 180 degrees. Okay, so if an angle is x, its supplementary is going to be 180 minus x degrees. Okay, so again, with complementary and supplementary, they can be adjacent to each other. And so adjacent angles are just angles that are next to each other. Adjacent means next to. Okay, right now I'm adjacent to my iPad because I'm right next to it. So two angles that share a common ray. So that ray here is ray OA. They both share that ray. So they're right next to each other. Okay, they're in the same diagram. And then our last vocab word right now is angle bisector. So if we dissect this word bisector, we see bi and then sector. Bi means two, sector means intersect. Okay, so a bisector, an angle bisector, is a ray that divides an angle into two congruent angles. So the angles are congruent, which means their angle measures are equal. Okay? And you'll notice that in this diagram, you see that they have the tick marks here indicating that those angles are congruent. You could also see an angle, like if I draw this angle with an angle bisector here, you could just see these angle swoops represent that those are congruent to each other. Okay? So the last thing for this video is we're going to be dealing with a lot of diagrams in geometry. What can we assume? What can we not assume? So you'll see, what can you assume? You can assume straight lines. So like up here, if I gave you a problem like this, but I did not tell you the 40 and the 140, you can assume that angle MOP is a straight angle. That is a straight line, so we're dealing with 180 degrees. Okay? Collinearity of points, which means if I give you a diagram with 4 points on it, you can assume that those 4 points are collinear. They're on the same line. Okay? What can you not assume? You cannot assume right angles. So let's say you got a diagram and it looks like this. That sure looks like a right angle, but unless you see the little box, okay, you cannot assume that it's a right angle. We need the box. All right. Same thing with congruent segments and angles. So like if I draw two diagrams, a segment here and a segment here, I cannot assume they're congruent unless if I give you a congruency statement or they share tick marks. Okay. So they each share one tick mark. That means that they're congruent. Congruent angles, again, we need a congruency statement or the corresponding angle swoop marks, which I talked about up here in this diagram. All right? So make sure we're not assuming. That's going to be the biggest thing. Don't assume just based off a diagram. We need math to justify how we're setting up these problems, to justify what relationships we're going to use. Okay? So that's this first video, is just talking about vocab. In the next video, we'll start applying these relationships